On the dividing polynomials worksheet, look at number 1. We have m squared minus 7m minus 11 divided by x minus 8. We take x minus 8 and we put it on the left side of the box. So x minus 8, x, and then minus 8. Oh, sorry. They're m's. Yeah. Sorry. Okay. Number 1, yes. Now, we always take the first term and we stick it in the first box, m squared. And if I take an m out of m squared, what's left? M. And then I take m and I multiply it by negative 8 and I get negative 8m. I add a column, and this box need to add up to be negative 7m. I already have negative 8m. I need to add 1m, or just m, plus m. Well, if I take an m out of m, what's left? 1. And 1 times negative 8 is negative 8. And this box need to add up to be negative 11. I need to subtract 3. This would be negative 3. And remember, anything that comes after this line is a remainder. And you can see that because, can you take an m out of a 3? No, there are no m's to take out. So everything there is a remainder. How do we deal with the remainder? You write plus, and then you write the remainder, negative 3 divided by m minus 8. So those two boxes add to negative 11. This box and this box need to add to be negative 11. Okay. Look at number 10. 42x squared minus 33, and we're going to divide that by 7x plus 7. I put 7x plus 7 on the side. All right. And I stick the 42x squared in the box. If I take of 7x out of 42x squared, what's left? 6x, and then I take the 6x and multiply it by the 7x, and I get 42x. Now, this box and this box need to add up to be not 33, not negative 33, 0. If you look at this numerator, it's actually 42x squared plus 0x minus 33. It's missing the x term. It jumps straight from x squared down to constant. So it's always a good idea to look at your numerator and see if anything's missing. You have to have your numerator in order, x to the fourth, x to the third, x squared, x, and constant. So whenever you're dividing, take a look at the numerator, and in fact, the denominator too, and make sure none of the x's are missing. In this case, I am missing the x term, so I put a 0x in its place. And 42x and this box need to add to be 0, negative 42x. If I take a 7x out of negative 42x, I get negative 6. And negative 6 times 7 is 42. And I don't, negative 42. I don't want negative 42. I want negative 33. I need to add 9. And the remainder is 9, so I write plus 9 over 7x plus 7. Okay. Now, let me show you the shortcut. Nope, this is the hard way. The long way always works. No matter how you divide polynomials, the long way always works. The shortcut way only works if your denominator is x plus a number or x minus a number. So if I have x plus 7, it would work. If I had x minus 4, it would work, But anytime you have like 2x plus 7, the shortcut won't work. Or if the denominator says x squared, the shortcut won't work. Okay? So the shortcut will not work on number 9 because there's a 2 in front of the x in the denominator. It won't work on number 10 because there's a 7 in front of the x in the denominator. It won't work on 12. Would it work on 18? What's wrong with 18? Not only is the denominator backwards, but the numerator is not in order. So number 18, you have to put it in order to divide it. K to the third minus 5k squared plus 8k plus 4. And then the shortcut is not going to work on number 20. Let me show you the shortcut using number 1. M squared minus 7n minus 11 divided by m minus 8. Well, I want to show you that I get the same answer. Okay? Here's how you do the shortcut. You make sure that the denominator is variable plus a number or variable minus a number. No number in front of the m, no squareds. Okay? If you have variable plus or minus a number, the shortcut will always work. And what you do for the shortcut is you find the root of the denominator. What is the root of the denominator? If the factor is m minus 8, the x-intercept is 8, or the m-intercept, I guess. M equals 8. And if you can remember, that's the hardest thing you have to do, is remember to switch the sign. Okay? I write the number 8, and I put it in a corner. Yeah, so m minus 8 turns into m equals 8. M plus 2 would be m equals negative 2. Now, I write all of the coefficients of the numerator. 1, negative 7, negative 11. 1, negative 7, and negative 11. Then I draw a line, and I'm just going to do this pattern of multiply, add, multiply, add, multiply, add, and that will give me my answer. The first step is to drop the first number down. And then you take 8 times 1, and I get 8. Negative 7 and positive 8 turn into 1. 8 times 1 is 8. And negative 11 plus 8 is negative 3. And that is a remainder. Okay, and you'll get used to this step. It looks really strange right now, but you'll get used to it. And this was x squared, x and constant. And my answer is now one number less than x squared. So I started with an x squared, I'm going to end with an x. This is at 1x plus 1 with a remainder of negative 3. X plus 1 plus 3 over x minus 8. And that's what we got when we did it the other way. Okay, look at number 2. Number 2, what number goes in the box, in the corner? 6. N minus 6 turns into n equals 6. I put a 6 in the corner, and then my coefficients are 1, negative 1, and negative 29. Everybody understand that? Draw the line. First number gets dropped straight down. 6 times 1 is 6. Negative 2 times 6 is 4. Oh, sorry. Thank you. Sorry. There we go. 6, so 5, 30, and negative 1. 6 times 5 is 30. So the pattern is drop the first one, 6 times 1 goes here, add, 6 times 5 goes here, add, and the last one is always the remainder. Yes, this is a division shortcut. Yep, this is called synthetic division. The box method will call that long division, and then this is called synthetic division. It's much faster. But it doesn't always work. It only works if the denominator is x plus 2 or x minus 8. Okay, what is the answer? Well, my original equation was x squared. So the answer is one number smaller than x to the second. It's x to the first. 1x plus 5 with my remainder of negative 1 over x minus, or actually it was n, but whatever. Okay. 9 it won't work. 10 it won't work. Let's do number 11. Number 11, x squared minus 74 divided by x minus 8. What do I put in the corner? 8. And what are my coefficients? 1, 0, negative 74. Does everybody see that I'm missing an x term? Whenever you're doing division, you need to check the numerator and the denominator for missing terms. 1, 0, negative 74. All right, drop the 1. 8 times 1 is 8. 0 plus 8 is 8. 8 times 8 is 64. And my remainder is negative 10. What is the answer? X plus 8 plus my remainder is negative 10 divided by the original x minus 8. All right, let's do number 17. What should we do with number 17 to begin with? It needs to be in order. Okay, when I set the bottom equal to 0, what does k equal? Negative 3. Negative 3 goes in the corner. And then when my coefficients are in order, what's the first one? 1k to the third. The next one would be negative 4. And then negative 30. And the last one, negative 18. And I'm not missing any. I have k to the third, k squared, k, and constant. So we're not missing any variables. Okay. Same pattern. Drop the first one. Negative 3 times 1 is negative 3. Negative 4 and negative 3 make negative 7. Negative 3 and negative 7 make 21. Negative 30 plus 21 is 9. And negative 3 times 9 would be, wait, that's a negative, plus 27. And my remainder is 9. What is the answer going to be in this case? So I started with x to the third, which means I'm going to end with x squared. 1x squared minus 7x minus 9 plus 9 divided by, anyway, I switched it to x's, sorry, x plus 3. Does that make sense to everybody? Well, whatever you started with, this is going to be one smaller. Well, I divided, so I had x to the third, and I divided it by x, and a bunch of other stuff, so the result will be x squared with a bunch of other stuff. So if I started with an x to the fifth, I would end with an x to the fourth. And, right, if I started with an x to the fifth, and I divided it by an x squared, the answer will be x to the third. But you can't do synthetic division when you have x squared. But if you did long division, then if this is x squared, and you put an x to the fifth here, then your answer will be x to the third. So your numerator degree will always equal your divisor degree and your answer degree added together. Yeah. All right. Need to do this worksheet. I would use synthetic division where you can, and then on some problems you have to use long division. You don't have a choice. Good luck.